Okay, for 0 to 2, the average distance of a point on the graph y equals x squared to the line x equal to is. So the average distance, let's just go ahead and graph this. This is going to be, let's see, y equals x squared and x equal to 2. So x equal to 2 is going to be 1, 2, this vertical line here. And y equals x squared, so at 2 goes up to 4, so 1, 2, 3, 4. 1 goes to 1, 2 goes to 4. So this is our graph here. And it says, find the average distance on the point of the line, this thing, and this line. So we're asking for, if I have all of these distances here, these are all the distances between all the different points, what's the average distance? In other words, if I could create a box, this is kind of how I think you should think about it, or to create a box like this, where this area fills in this area completely, what this does is it gives us the exact same distance here for both, this situation and this box here. But it gives us, this is the average distance between 2 and this function. So what's weird about this is that we're talking about not the normal, where x, I think normally you'd think about these distances here, but here we're talking about the other way. So what you can do instead is actually just make this thing like the inverse function, just flip it completely. And if y equals x squared, that means x equals the square root of y. So we're just going to look at the square root of x. And instead of x equal to 2, we're going to look at y equal to 2. I'm just flipping x and y pretty much. Okay, so what that gives us is going to be, let's see, it's going to be 1, 2, 3, 4, 1, 2. It pretty much just flips these two axes, just kind of like this. We're going to flip these two axes. And we're going to get something like this. 1 goes to 1, the square root of 1 is 1, and the square root of 4 is 2. So it's going to look like this. And this is our y equal to 2 line. So now we're talking about these, the average distance of these heights. And this is more what we would think about in our problem. You can solve it either way. You can actually solve this using the y values. You'd have to use the y values for this one. But this allows us to use the x values. So this is y equal to 2. And then, of course, this is the square root of x for our situation. I just flipped x and y again. Okay. So it's gonna be the same answer no matter what we have here. So what I'm gonna do is I'm gonna find the area of this portion here, and then I'm going to divide it by this length here. And what that does is it creates a box such that this area, a different color here, this area completely fills in this area, and it tells me this height here. If I divide it by this base, so this is going to be my base, it will give me this height, and that height is the average distance. So all I need to do is find the integral. Again, x is from 0 to 4 here. Well, the top portion is 2 minus the bottom portion is the square root of x dx. This is going to be the entire area. And now all I need to do is divide this area by this base length here. And that base length is the same thing as this length here. It's just 4. It's from 0 to 4, so it's 4 units across. Okay, that's going to give me 2x minus, this is x, this is 1/2. So I would have had to come from 3 over 2. I'd bring in a 3 over 2, so I need to cancel that. So I'm going to put 2/3 in front. X to the 3/2, evaluated at 0 and 4. Of course, the 0 just is 0. So we really only need to plug in 4 into there. So we're going to get 4 times 2 is 8. And then 4, I'm going to do the square root first, is 2. 2 cubed is 8. So 8 minus 2/3 of 8 is just going to be 1/3 of 8. And 4 over 8 is 2. So we're going to get 2/3 total. And that gives us C.